Attendees are in listen-only mode.
Hi everyone, we're just gonna wait a couple minutes until a few more people join. All right. Good morning, good afternoon, and good evening, everyone. Welcome to this webinar, and thank you all for joining. We're very excited to have you here. Today, our webinar will be brought to you by Paolo Knirsch. He's our product manager for NXP's i.MX applications processors, as well as Nick Schultz, who is a field application engineer over at Crank Software. As you all probably already know, we will be discussing how you can enrich your user interface for your next generation IoT design. And we have, Paolo and Nick are great speakers, and they're super excited to share with you how you can do that. Again, my name is Ethan Fernandez, and I'll be hosting the call. Do know that you can type in any questions you have throughout the webinar, and we will have time at the end to answer them. So without further ado, I'll hand it off to Paolo.
Thank you, Ethan. Hi, everyone. Thanks for your time in joining us. So today we'll talk about rich user interfaces, and I will discuss a little bit how the market trends are progressing and the hardware requirements that we do have to support up-to-date designs in the i.MX solution that NXP presents. And we have the privilege to have Crank Software, a partner of NXP, with us. And they will be presenting graphic user interfaces software development here on the webinar. So let's get going here. Okay, so nowadays we experience a broad change on the consumer electronic devices. So every day we interact with our smartphone almost every hour, and we have tablets and so forth. So that's really changing the way consumers, people expect to interact with electronic devices, leading to several changes on user interfaces. And a lot of embedded designs start to have new requirements, both in smart home, building automation, medical devices, industrial applications, and really you name it. So I need to go to the next slide. Sorry, guys, we are getting going here. So in this IoT revolution, as it goes and progresses, we see that the interfaces start to be really a relationship with the user. So you have the additional video, 3D graphics, audio, voice, gesture, vision, touch. So multiple senses in this interface between us and electronic devices. The level of processing capability and accuracy of response is increasing greatly. requiring every more processing capability of the IoT devices. And connectivity is really a given. High-speed bandwidth talking back to the cloud, allowing you to really be providing specific content and carry user information wherever you go as the knowledge bases start to be on the cloud. Now, talking a little bit about the trends that we see and some data points. So today, video streaming is about 79% of the internet traffic. We don't have as predominant the cabling for analog signal or digital specific signals, but everything is moving to web-based, cloud-based, and really going to 4K and with the high dynamic range to improve the image, right? And we have several big consumer-oriented customers driving this change. When you go to the voice realm, you really see that 20 to 30% of the searches on the web are already done by voice, a new way that we are interacting with electronic devices now. TVs are getting slimmer, and that's pushing audio interfaces to be separate products, a trend that also penetrates on embedded applications. So DSPs, dedication hardware devices, are migrating to ARM solutions, benefiting of the huge ecosystem and knowledge base of embedded developers. We see machine learning and also artificial intelligence on the smart homes, allowing to do things like face recognition, adding vision to the interface that we have. So in the interfaces on the home, you really have a seamless interface with multiple services. So with one access point or interface point, you can control multiple stuff from buying coffee, turning on lights, and so forth. When we go to the industrial type of applications, we see applications getting portable with faster response, battery life really going down. And here's a key point of differentiation, right, with embedded applications. Usually you require 10 years of lifetime of your products and guarantee of supply and a broader temperature range of operation. So the same you don't find on typical consumer applications like cell phones. Usually the lifetime is about 2-3 years for a phone at most. So when you are really designing a user interface or embedded designs, you need to consider solutions that can provide to you the supply lifetime that you have. So the industrial interfaces are also changing, so operators are requiring more friendly to use applications, and there I talked already the machine vision moving from DSPs to the GPUs and ARM cores. And also trends on building automation, right? So with reliable connectivity and also a cloud-based knowledge. Now, talking a little bit about the key things when selecting and the hardware for these products, we see the importance of having a portfolio of options you have for development. The cost of developing software, developing the hardware is not small, and you need to make sure that the platform you select really can scale up and down. I talked about the 10-year supply guarantee that is offered also in the i.MX devices, and the easy of use. You need to have a whole solution platform to start your development, and that's why NXP work with companies that are leading on software and ecosystem like Crank that are here today with us. So when you consider then hardware and application processor for your embedded design, You start to care about things like 4K decoder, 4K resolution, video capability with H.265 encoding decoding standard, 3D graphic acceleration that can provide you the performance, and Nick will show all the neat stuff you can do with it, benefiting from it. High fidelity audio, so you start to embed high quality of audio in your design, not bringing that to external DSPs anymore. The processing capability now with the Cortex A53s and 64-bit cores, and a lot of flexibility in terms of high performance DDR memories that also are low power. And you cannot forget about the high speed interfaces to be connected there. So PCIe, for instance, to connect with Wi-Fi chipsets and allow a great throughput in the Wi-Fi with great range and lower power consumption. You see on the pictures that I bring here several different applications. So you have like a industrial tablet, you have entertainment, both you see now in appliances, more higher end appliances to start to have really sophisticated user interfaces. At the right, you can see a smart robot, for instance, to take care of your kid, especially if you live in China, is very popular. Digital signage, really the images standing out of the display and moving on. And for instance, very common to us now to go to a gym and have a fitness equipment where you can see the CNN apart from having the controls of your the equipment that you are using. And to start to close up on the message that I would like to convey on the hardware and considerations and trends of the embedded designs, I bring this last generic block diagram of a smart IoT application. So here at the left, you see high-speed interfaces. And using example PCIe and SDIO to connect to the Wi-Fi, Ethernet, now going to gigabit Ethernet, SD cards for memory, USB Type-C with great throughput. On the smart performance, you start to see adoption of the LPDDR4 even on embedded designs, and still the DDR4 and DDR3L. Transactions between the DDR and the processor starts to go to 3.2 giga transactions per second. So getting really fast. So the core has a lot of throughput to really process quickly, going up to 1.5 2 gigahertz of processing speed. On the topic in question here of interfaces, you have multiple interfaces used. So HDMI 2.0 used connect to low cost and even high performance 4K monitors for broader, bigger screens. You have a local MIPI DSI that you can drive, for instance, a 7-inch or 5-inch OLED display at 1080p. Several audio interfaces, digital microphones, and outputs for codecs. And also here to start to play and have vision there, you have the camera input. So you can even do and have companies doing vacuum cleaners that have vision on it to detect what object they have in front of the vacuum, learn about this object, and go around it. So face recognition also is there, right? So you have a door lock access control where it recognizes your face and it opens the access. So we start to get a really common place as we move there. So now that's a brief point here, and I will transition to Nick that will guide us through the world of the graphic interfaces here. Nick, please.
All right. Well, thank you, Paulo, for kicking off so nicely. So as Ethan mentioned earlier, my name is Nick Schultz. I'm a field application engineer here at Crank Software. And today I'm going to talk to you about Storyboard Suite and how you can create fantastic user interfaces on the i.MX 8M processor. So today, when we look at the state of the industry, we see a world that has embraced embedded computing. So much so that what was once considered state-of-the-art a year ago can now be seen as dated or merely a standard feature in new products. In many cases, these products are part of the larger IoT landscape, so the user interface will need to combine network connectivity, streaming multimedia, compositing multiple hardware layers. In short, expectations from end users have never been higher, and more often than not, the first few moments of interacting with a user interface will determine if someone chooses to adopt or reject your product. Not only does the UI need to look good, but it needs to have great performance as well. So your animations need to be smooth, your touch input needs to be reactive and snappy, and traditionally requirements like this would only really apply to desktop computers and high-end smartphones. But today, anything with a display on it is subject to these considerations and scrutiny. So Storyboard Suite provides a tooling solution that can help empower the designers and engineers on your team to create a stunning user interface on platforms like the i.MX 8. So quite frankly, why Storyboard and NXP? Well, NXP is one of the leading manufacturers of embedded processors, and they provide a diverse and full array of hardware options for you to consider when building your product. So we want to talk a little bit about scalability from our end. So it's important to note that Storyboard works across the full range of NXP hardware on multiple operating systems. So platforms like the i.MX RT running something like FreeRTOS, all the way up to the top of the line i.MX 8 series of processors running embedded Linux. You can use Storyboard to create engaging user interfaces on them. So regardless of where your hardware sits in the range of MCU to MPU, Storyboard can leverage its capabilities to deliver an optimized runtime experience for your platform. So if you think of the i.MX 8M and some of the capabilities and hardware pieces it has available to it, you could choose to make full use of OpenGL acceleration for rich graphics and smooth performance, or you could do something along the lines of saving GPU cycles for machine learning, and then in this case, you could leverage something like the G2D hardware acceleration so you could offload the GPU, yet still maintain a smooth user experience. At the end of the day, only you are going to know what's the right choice for your product, but you need to have a solution that's flexible to meet your needs. And these are needs that may change, from conception all the way to production. Some of the demos that we've done in the past with NXP, if you look at content on the screen here, these have all been presented at major trade shows. So at the far left, we have the e-cockpit demo. This was shown at CES, and this was running on the automotive variant of the i.MX 8. But important to note, it had 4 screens all simultaneously outputting content at 1080p. There was rich 3D graphics, acceleration in the cluster. We had maps view, integration with rear view camera, as well as a heads-up display. At Embedded World this spring, we presented 2 demos, the connected oven and kiosk. Both of those had the Snips voice recognition software, so we're leveraging the power of the i.MX 8M hardware to handle voice recognition and translating voice commands into logic that you can use at runtime. The oven used the voice framework to listen to voice commands. It would then fetch recipes from an online database. Based on that recipe, you then configure your oven based on your query. If you look at the movie kiosk, again, we use voice commands as a starting input mechanism, but it allowed you to do things like you could choose to purchase tickets, play trailers. All of the output of this was also, of course, in 4K format. So the one thing that all of these demos have in common is that they all feature rich, high-performance UIs, but they're running on top of a sophisticated, multi-layered set of software underneath. So you need to be able to do more than just draw a nice picture to the display. You need to be able to handle voice recognition and do processing in the back end as well. All of the content that you're going to be seeing today, so especially when I kick over and do a little bit of a live demo, it's going to be based off of our demo image for the i.MX 8M. This demo image is available on our website, and it'll be pre-configured with the movie kiosk demo, 3D cluster, as well as the IoT house. So some of what you see will be similar to what's already on there. But when you download it, you simply have to flash it to an SD card, and you're ready to begin evaluating and developing with Storyboard on the i.MX 8M. So why is Storyboard different from some of the other options out there for building UIs and embedded applications? So the first thing you need to do is you need to actually start understanding some of the teams and the processes that happen when you're working in embedded. So if you think of the product teams, today they're a mix of engineers and designers, and thankfully right now they work together as equals to create and develop your product. Traditionally that wasn't always the case, and it was usually heavily made up of engineers, and outside of the initial design and scope, the designers really had very little say during the development process. Now that this has changed, so the designers are included in the mix, the workflow is much different. So you need to be able to react to changes all the way from concept realization at the beginning to iteration down the line. Looking at the traditional workflow that I alluded to a little bit earlier, the design teams and the engineers would work in lockstep. And this wasn't really the most optimal. So the design would then provide a spec to engineering. Engineering would take that spec and start to implement the UI. Once that phase was complete, they'd usually gather, have a review. More often than not, there'd be some discussions, some potential conflict of decisions people made that might have compromised the design or affected engineering and so forth. And then they'd start up this iteration cycle again. And this is a very slow and difficult process to manage, as well as sort of change if needs be. So every cycle that you go through, more and more engineering effort would be invested, which in many cases make changes time-consuming or in some cases impossible. So if you didn't catch issues early on in your design, you might be forced to live with them through the release of the product. Ideally, you want to work in this parallel workflow that we have on screen here. And Storyboard enables you to do that. So the design and engineering teams are able to work in parallel. What this means is that design teams are free to make changes to the UI without the need to engage the engineering team. Both teams are then free to iterate on concepts and ideas that originally would have likely been deemed too costly or impossible to implement. And your design is better for it. You can iterate all the way through your development cycle, and you're able to actually enact the best product possible. So how do we help facilitate this? Well, it starts at the beginning when you look at the design team and what they're working with. So a lot of times designers have tools that they use to create the look and feel of the UI that you see on the end product. What we allow you to do is we allow you to import that content directly from some of these tools. The leading tools on the market for this are things like Photoshop and Sketch. And what we do is we can import that content directly from the tool. Their design will come into our environment exactly the same as it was in their environment. And then you're ready to manipulate and provide behavior to the content in Storyboard. So there's no time spent slicing up assets, doing costly packaging and handoffs to another team that's going to implement it. The content comes in and it's ready to manipulate and work with. On some of the higher end systems, especially like the i.MX 8, you've got full 3D OpenGL ES support. So we support the OBJ and FBX file formats for direct import, and then you can actually bake in animations to your 3D assets as well. Once those assets are imported, all the elements are available for you to manipulate and control in the design tooling. So we allow you to create your content in the best way possible and then manipulate it for display. Of course, when running on these platforms, you can display rich information all the way up to 4K resolutions. So it allows for really high fidelity and really compelling user interfaces. When you've imported your content into Storyboard, you need to be able to do something with it. So whenever you need to, create a polished look and feel, no detail, no matter how small, is insignificant. So Storyboard Suite includes an animation timeline editor, so that allows you to have fine-grained control over the creation and behavior of your animations. Designers can then preview the animations directly in the tool frame by frame, and you can make changes quickly and iterate quickly without having to, relaunch your application or deploy onto hardware to test. So this greatly helps speed up your design process, as well as it allows you to get the look and feel right. I'll be demoing a little bit of the animation timeline as well to give you a better taste of what we can offer. And then really the big key to all of this is iteration. So, we talk about it a lot, I harp on it, I repeat it, but some of the real power that we bring to the table is that we allow you to re-import new content at any point in your development cycle. So, as we all know, good design requires revision and continual refinement. So if you're working in an environment that doesn't embrace this idea, then you really can't expect to arrive at the best version of your product. We encourage you to embrace change, our product does, so that way you can come up with the best content quickly and efficiently. So I'm going to quickly jump out of the slides right now. I'm going to pop into our tool. I'm going to give you a little bit of a quick walkthrough of some content. I'll import some 2D as well as some 3D. And obviously I'm not a designer, but I'll do my best to make some rich, compelling animations and then show you something that was created by one of the pros we have in-house here. So here we have the open version of Storyboard 5.2, the latest release of our content. And I'm just going to start off by importing a file from Photoshop. If you've seen any of our demos in the past, the IoT house perhaps, then this content will likely look familiar to you. But I have a PSD here. I'm going to bring that in. And we have some content on display. This already created us a screen and some elements, as well as something to work from. So this is something that one of the designers created for us, and now we can go ahead and manipulate it directly. So I spoke a lot about animations and creating compelling content. So I'm just going to go ahead and jump right in there. We see here we've got some 2D image assets here. We've got a label, a little button in the middle, as well as another label down below. So the first thing that I want to do is I actually want to do something with it. So I'll quickly just zoom this in so it looks a little bit nicer for you. So if you think of this as your first entry point into your application, it might be nice if you click the little home button in the middle, it faded out, your other elements moved off screen. So I can start doing that by just hitting our little record animation button at the top here. You notice the screen has got this red bar on it. So anything that I do is now being recorded and then will be transformed into an animation that I can edit and refine. The first thing that I want to do is I can move this content. So I'll slide this guy up. Take a snapshot, so that'll create a step. Move the label at the bottom off. Take another snapshot. And then I'll go ahead and I'll just hide this. If I hit the stop, that recorded all of that content for us. We can go ahead, give this animation a name, set a frame rate, and then really dive in and start doing a little bit more to smooth it out. So I'll call this something like hide menu and give it a frame rate of 60 seconds. If I hit OK, you can see that opens up our animation timeline editor. We have 3 different steps. They're all spaced out. The tool did its best to align these. So if we just go ahead and we preview that right off the bat, it's okay, but it could be better. And coming from someone with an engineering background, when they say it could be better, it's probably not okay. So the first thing that I want to do is I actually want to change these 2 pieces to move at the same time. So I'll go ahead, change the offsets. And we just did a hide on this content. It would actually be a lot nicer if I faded that out. So we have the ability to do that too. Inside this area, because we didn't capture it right off the beginning, we can actually go ahead and add another step and some new content to it. So again, if I click our add animation step, I can go ahead and I can then grab a handle to the transparency or alpha of that content. Doing so, I'll just create a variable for it. Say finish. We can grab that, and then we can do something along the lines of fading that out. So the first thing that I want to do is take it from the current animation. We'll set it down to 0. Say OK. You can see here that created a new step for us. We're modifying that variable. The last thing I need to do is I actually need to hook it up to the control. So I'll find that up here. I'll say OK. And oops. I'll just go ahead and recreate that there. There we go. And then instead of doing this after the 2 pieces move out, I can go ahead and I can drag that over. So if we start changing our offsets, we get something that's a little bit more polished. And then the last thing that I'll do is I'll change this hide flag just to map up to when we're no longer visible. The reason I'm doing that is because if you press it, of course, once it's hidden, you don't want to have a control that can trigger anything. We simulate that again. It looks a little bit nicer. We can then quickly hook that up. So if you want to bind that to a press event on the button, trigger our animation, hide menu, select finish. I'll save that and then I'll simulate that quickly. So you see here we have our application. If I press this button, again it hides and it fades out. So that's pretty good. I also have the fully blown application over here, so we can take a quick look at content or an animation that was created by a designer or someone whose background really is in this field. So I go down, you can see we have lots of different animations in our timeline, but this allows you to really get fine-grained control over your content. If I open this up, you can see I've got lots of different steps with complex timings, some things that are durations over time, some things hard changes. And again, if you were to go ahead and simulate that, you can see there's a lot of stuff going on. You can also go ahead and use this to step frame by frame through your animation. So you can really break down and understand the granularity of what's going on here. I'll go back to our original sample here. So that's working with 2D content, but a big part of what makes these processors so compelling, especially the i.MX 8M, is the ability to leverage 3D OpenGL acceleration. So we also have the ability to blend this in seamlessly. So right now we have this image of a house in the background. I can toggle it on and off. That's just there as a placeholder. I'm actually going to replace it with a 3D model of the house, and then we can interact with it. So I'll go ahead and I'll delete this piece. I'll add a new element, 3D model, say finish. We can then choose to import a model. In this case, I want to grab our house model. You can see it's in FBX format. Say finish. Importing that in. That'll create it to an internal format for Storyboard that has animations baked into it. So if I say OK, we'll get the option to resize the model to fit our control and our content. I'll say yes. And then one thing that's important to know is we allow designers to create the model however they'd like, but then we also have control of some of the elements once it comes into Storyboard. So you'll notice it's set off in the background, but we can go ahead and actually edit that directly. Other things like lighting as well, shading models, we have the ability to update all of that. So you can see here, we have those controls. So if we move to an unlit style, we can boost up the ambient lighting as well, make it a little bit brighter. And then we can actually go about and change our camera orientation and where everything is set up. So in this case, if I want to bring ourselves a little bit closer, pick something like 350. And then you can also do things like control rotation and stuff like that. So if we update the azimuth value, we can go ahead and manipulate that. So what I'll do is I'll go ahead and I'll do another animation recording similar to what we did before. Create an angle variable. And then I'll toggle our recording animation. This is going to be pretty simple since all we want to do is spin the home. So we've got something that's updating at real time. So I'll just go ahead and instead of 0, I'll put 360 degrees. Then I'll stop. Call this spin home. Again, keeping our high 60 frames per second smooth frame rate. And we have this now in the timeline. So if I go back out, you can see we have our spin home and our hide menu. We can go ahead and then change some values on this. In this case, our duration is only 500 milliseconds, so that's a little bit fast. I can go ahead and change that to be something along the lines of, say, 3.5 seconds. Again, we can kick this off and preview it. Moves a little bit slower. Looks all right to me. And then we can actually start doing this complex behavior with 2D and 3D content. So if I go back to our application here on this screen, I can kick this animation off from the beginning. One thing that we might want to do is have it also repeat on itself as well. So it's a seamless loop spinning around and around. I can hook that up. So when we show the screen for the first time, kick off this animation, spin the home. And then we can also bind on to when that animation is complete and just start it off again. So again, it has that endless looping behavior. So if you're just sitting idle, the users know something's happening on your device. It hasn't frozen and locked up. So again, doing a similar thing. Except instead of a post event, we can actually bind on to the complete. So if I start typing there, you can see we have this spin home animation complete event to key off of. Simply kicking it off again. If I save that and we simulate our application again, you can see now we have this home that's spinning around. And again, it looks all right. There are a few things that we could tweak to make it a little bit better. First thing that we're going to do is we're just going to change the camera elevation a little bit more to make it a little bit more of an overhead view. That's better. Simulate that one again. Perfect. So that was creating an animation from scratch, and again, very simplistic. I'll concede to that, where we just spin it around on an axis. But I mentioned that you could also bake animations into your FBX format, and that's what we have here. So I also have the ability to import an animation. This was something that was created in a 3D tooling environment, so something where the designers have full control of their content. I can click this import animation, bring our created animation over, select finish. You'll see this pops up as something that we have available to us as well. If I jump in, there's a lot of different steps set up and frames. If you were to simulate it, you can see here we're pulling the roof off as well as other elements and moving the camera in. If we want to control that, then we can kick that off. So as the application loads, the model spins around. When the user presses their main button, we hide the menu content, stop the spin animation, and then trigger the look inside the house view. So if we want to go ahead and do that, it's fairly simple. First thing that we want to do is once the hide animation trigger happens, we can go ahead and add another event. So on press, first thing that we want to do is actually stop the spin animation, since depending on where the animation is currently at, you might not like the direction you're going from, so we want to control that. So I'll just stop that. I'll reset the house to be the front view. Reset that back to 0. Finish. So you can see here we're building up our behavior all off of the press event. And then finally, after everything has been reset, we can go ahead and we can kick off the zoom in animation. Say finish. If I save that and simulate it, our home's spinning around just waiting for the user to interact with the device. I click our button, we reset it, and we zoom in, and we can see all the content inside. That's awesome. The last piece of this puzzle is actually deploying this and running it on the i.MX 8. So what I'll do is I'll open up this export configuration dialog, and we actually have the ability to export our application over SCP. I have a webcam here showing a target on my desk where we're running our demo image for the i.MX 8M. And you'll just have to bear with me as I juggle the screens here. And you can see that's just running the main demo image. You have a couple different options, movie kiosk, IoT house. Well, we can actually go ahead and push that. So if I hit run, you can see here we've reset. We have our new application running. And then if I go over and I touch the content, everything fades out and it deploys. So that's part of the story that makes working with Storyboard very compelling. You're able to actually work in your design tool, build up complex behaviors, control your application and the look and feel and vision of it, and then very quickly test it. And then at some point, nothing obviously takes the place of testing on real hardware. Deploying is also a very easy feature. So you get that real idea as to how things work on actual hardware on the screen that users will be interacting with. So with that, I'll probably hand everything back to Paolo. And thanks for paying attention, guys, and hopefully you found the demo enjoyable.
Thank you, Nick. So I'd like to share how we can make that all easy for you to start playing and evaluating the solution we are presenting here. So first, Nick will share with us how you can get going with Crank.
Absolutely. So, as I mentioned earlier, there will be a demo image that will be available shortly for you to download. It'll be found on our website. So if you go to cranksoftware.com/demo images, there will be links to the NXP section and all the different platforms we support. You can also get a free 30-day evaluation of the Storyboard, and that is the full unlocked product. So we don't hamper it in any way. This product ships with runtimes that you can deploy onto your i.MX 8M development board, and you're free to do with it whatever you'd like and prototype to your heart's content. We also have documentation available online, as well as a YouTube channel with a lot of great content about getting started, tackling certain tasks in the tool. And one thing to take note, a lot of those videos and content and demos that we have, they were actually done by designers in-house. So these were people that don't have an engineering background. We really are, pushing that engaged design, get better content story. So we have our designers building this up for you, and no matter what your background is, you should be able to create really rich, compelling user interfaces with our product.
Thank you, Nick. So as the hardware platform here, we have the i.MX 8M evaluation kit. This kit, apart obviously for having the application processor 8M, it's a Cortex A53 together with a Cortex M4 for real-time requirements. It also have several memories. LPDDR4 has a 16 gigabit eMMC and also a SPI flash, apart from the mini SD card connector. So you have connectors for the HDMI to have a TV or a monitor, a MIPI DSI for having local displays, 2 camera inputs. Also, you have the embedded Wi-Fi and Bluetooth, audio jack with DACs, Ethernet, USB 3 connectors, as well as PCIe, and you can debug using the JTAG or the serial USB connector there. So NXP offers a Linux, BSP, Android, and also FreeRTOS already ported to the board. So this board, you can get it on the NXP website or with our distributors. And we also offer other evaluation accessory boards for your convenience. So there's a MIPI to HDMI converter, so you can develop applications with 2 HDMI TVs or monitors. We have a local display with MIPI DSI and also a camera board. So you can start your evaluation of the solution with no hardware development up front. NXP makes a lot of technical collateral to support you with your development and evaluation. Here are the key websites where you can find the information. Not only the product data sheet, reference manual, errata, but as well as the power consumption information, hardware design files, schematics, Gerber files, simulation models, and so forth. And also very relevant is the NXP community, when you can get free technical support on a very convenient way. Now with you, Ethan.
Okay. Thank you, Nick and Paolo. We do have a few questions, actually. There were a couple that we did answer already through the question box, but we'll ask the ones that haven't been answered yet, and then maybe we'll get back to the other ones. So, Nick, we have one question for you, and they wanted to know, what is the price for Storyboard for one developer?
Yeah, and I guess that was Harry who asked the question. So cost of Storyboard Suite for one developer is $6,000 US. The purchase requires a 1-year support and maintenance fee, which is $1,500. After that, support and maintenance is optional, and that covers the developer. If you're looking to ship product and deploy content in our software in the field, then there'd be a discussion about run times, but that's usually something that, depending on your business case, the values can change.
Awesome. Thank you, Nick.
No problem.
So we do have some time. So I know there's been a few questions that were asked about i.MX 8M that our technical expert Mark Ruthenbeck has answered. But I'll go ahead and for those who may not have seen them, I'll just go ahead and repeat those questions. So the first one asked, does i.MX 8M support debayer from MIPI CSI raw sensor? And what is the performance of this module? And does it support 4K at 60 frames per second from MIPI CSI to 4K HDMI? And our answer is that the i.MX 8M supports 2 MIPI CSI interfaces. These interfaces have 4 lanes, which each operate at 450 megahertz. And both interfaces supports debayer format, and the resolution is dependent on the frequencies used, so typically operates at 1080p inputs. Nick, we actually have another question for you.
Sure.
Does Storyboard generate C or C++ code?
So Storyboard doesn't actually generate code. So the tooling that you saw me use generates a model. Inside that model, there's descriptions of your content, as well as the ability to use Lua scripts for behavioral logic and glue. Then the other side is we have an engine that is deployed to the hardware. So that is the C code that does all the rendering and the behavior. So that's deployed, and then at runtime, it loads up your model and executes it.
Great. Thanks, Nick.
No problem.
So let's see. Okay. So yeah, I'll continue with the ones that were asked earlier. So for i.MX, they were asking, is there any way to receive picture and video via MIPI CSI custom camera? And our answer is that the MIPI interface is programmable, and we have customers using this interface on multiple brands of cameras. Again, we have another one for i.MX. Is the automotive grade Linux going to be supported by the i.MX 8M officially or only by the community? And the answer is the i.MX 8M is not an automotive qualified part. And then lastly, what is the maximum length of mini SAS cable connected to MIPI CSI camera? And we do need to do a bit of digging for that, and we can provide you a more in-depth answer if we have your email, so we can give you a better answer after. So that's it for questions. We will be sending out a follow-up email in the next few days that has links to the video file and a streaming link, as well as some other collateral that we may have for you. So again, thank you all for joining the webinar, and we appreciate you attending, and we were very excited and happy to present to you. And with that being said, this will conclude the webinar. Thank you.